Ladies and gentlemen, it is Wednesday. This is another version of Ask That, which means it's a glorious Wednesday and a glorious edition. And today we're going to have a very random conversation with an unrandom person. Brandon Satrom, how are you?
I'm great, Clark. Happy Pi Day. How are you?
Happy Pi Day. And on this Pi Day, we're going to talk about, devices and Kickstarter, and we're going to see where this whole, glorious lunchtime conversation just takes us. Sound good?
Sounds great.
So before we start rambling, because that's probably what you and I will get into given our history and pedigree, why don't you tell the lovely audience who you are?
Yeah, absolutely. So my name is Brandon Satrom, and I have been in the technology world for 18 years or so. Spent a lot of time in software. I know, I'm getting old. Spent a lot of time in software. Have done worn a lot of different hats over the years. Recently, I have tried to become an aspiring maker and tinkerer and general bricker of all manner of hardware devices. And part of that has led me in a couple of different, very complementary paths. One is last year I started a maker education and publishing company called Carrot Pants Studios, and we launched a Kickstarter campaign for our first book. And then just over 3 weeks ago, I actually joined Particle, company that I've been a fan of and customer for many years. Joined Particle as their developer evangelist. So going on 3 weeks doing that and learning more and more every day.
I imagine that you are. I imagine you have all kinds of little devices showing up at your establishment there.
I do, absolutely. I'm drinking from the internet-connected fire hose. Right, so there. See, there's
hold on.
Yeah, they got all kinds of stuff.
Do it again. You got to get in a bigger frame.
All right. Oh yeah, that's right. It's not in the big. I can't pull it too far from the USB, right? Not.
So that is what?
So this is an internet button. It's actually a kit that we sell for the Photon. But this basically gives you some push button functionality on the device and there's a cool starter guide on how you can actually connect this little internet button to the internet. But at the center of it is and I'll unplug it so I can show everybody. But at the center of this thing is effectively the particle Photon, which is one of our two main current developer prototyping devices. And this is a small little Arduino compatible board with Wi-Fi built in. And surrounding that is really everything that Particle does, the secret sauce of Particle, which is the platform, a device cloud, the ability to flash these devices with new firmware over the air. As once you get this thing on Wi-Fi, really the sky's the limit in terms of what you can do with it. So this is the Photon. So this is the Wi-Fi version of that. And then the other one that I have here that I'm going to unplug also is the Electron. And this is the cellular connected board as well. And this thing is pretty sweet. It actually, there's a ton of tuning that's been done around making sure that even though it uses cellular, that it uses very small data packets, and it's really easy to flash over USB instead of doing OTA updates and things like that. So those are the current devices, and I'm sure we'll get into. There's also some new devices that Particle announced last month that are coming this summer.
Yeah, those look pretty exciting. For sure. But before we get there, let's you mentioned Kickstarter, so let's talk about what you did on Kickstarter and kind of your journey into making, if that's a good adjective of what we do these days.
It's one, absolutely, it works. That's what I tell people: making, breaking, whatever. I do a lot of both of those things. So about 4 years ago, Again, like I said, I've been in software for such a long time. About 4 years ago, I got to this point where I felt like I really wanted to get into the world of physical computing, looking over at the Arduino crowd and being a little jealous that they were getting to blink LEDs and drive motors and build robots and things like this. And so I actually grabbed a SparkFun Inventors kit that my wife actually gave me for Christmas that year. It's cool. That was a cool nerd Christmas right there.
Yeah.
And went through all the tutorials. It was just fell in love with with that entire space and with everything that I got to do, going through from blinking that first LED to building a little Simon Says game. And that's typically what those inventors kit gives you. Through the end, you're building a little Simon Says game that the kids can play with and some of those things. And after I got through that, I felt like, okay, this is awesome. I love this. And I felt like, all right, I want to keep doing more. But my big problem here is that this Arduino has an Ethernet cable, and I don't even know if I have an Ethernet cable in my house. So what am I going to do to get this thing on the internet? And that was around the time that I'd first heard of Spark, now Particle, and grabbed a Spark Core, their original device, and just kind of went nuts from there. Got and bought, as you know well, because you and I have known each other for years. Yep. Bought way too many devices: Raspberry Pis, BeagleBones, Tessel 2s, Pocket Chips. I have a board problem, for sure. But that was really the start for me. A lot of it was motivated by sort of my own desire to get into that side of sort of software plus hardware together and use my skills as a developer to expand into the world of hardware. But the other motivation was my kids, was actually starting to get we have 3 boys, and to get my older 2 especially interested in electronics. And I went through a lot of those early Arduino projects with my oldest, which was a really fun time and sort of, I think, awakened in me this desire to expose them to more and more, which we've done over the years. And the way that led to the Kickstarter is a couple of years ago, I had an idea. I was really thinking about what are the ways that I could get my youngest son, who's now 4, exposed to this world as well. And of course, he's not going to put resistors and breadboards and things like that. Not quite yet. A little bit too young. But I wanted to introduce him to some of the concepts in a very fun and engaging way. And so my wife and I decided to write a book that introduces basic electronics concepts through an illustrated children's book, where we introduce basically anthropomorphic LEDs and jumper wires and resistors and capacitors, and really give these concepts and components actual characters and stories that kids really are drawn to. So we wrote that book, and then last year we launched it as a Kickstarter campaign last August, I think. It's a blur now. So we launched that last August. I was successfully funded, so we had a goal. Our funding goal was $15,000. We raised 17, almost 18. I had about 250 backers, some really awesome and helpful friends and family and other families with kids that are really interested in getting their kids exposed to electronics as well, but we're sort of struggling with the right way to do so. So we launched that. We were successful. We got all the books printed and everything in everybody's hands as of a couple of months ago.
That you did. I got mine. We managed to blow up a couple of LEDs.
That's perfect. That's absolutely. If you're not breaking anything, then you're not learning, right?
That's right. So I know that we actually we've had a prior conversation about the Kickstarter and your kind of learnings about that. I think I and you were both surprised that the writing of the book wasn't the hard part, the making of the circuit wasn't the hard part, but really the campaign itself. Can you speak to a little bit of that? Because I think there's this facade on Kickstarter, like, hey, you put this stuff up, you make a video, and like you get all this money and support. Now you're funded. You go work on your thing, and if it's electronics, you're a year to 2 years behind before you ever see your stuff. But yet there's this whole, arts and creative side to Kickstarter, which I think people don't necessarily even recognize at times.
Absolutely. I think in general, anytime you're creating something new, I think the biggest thing that technical people like myself tend to underestimate is the importance and the value of marketing and really, really understanding how to do that right. I mean, I think there is a bit of and maybe this tendency has decreased over the years, but I think there is a tendency with Kickstarter to take this build it and they will come sort of attitude. If I just throw my idea up there, get a halfway decent video, then I'm good. But there is definitely an art form to planning out a Kickstarter campaign. And it starts with, as with any product, really understanding what your customer pain is, the kind of individual that you want to back your campaign. Is it a maker looking for an internet connected board? Is it a parent who wants to get their kids exposed to technology but doesn't feel confident enough to do it on their own? And once you've identified that person, you got to think about, okay, how am I actually solving a problem for this person? What am I actually doing to help make their life better? And then finding a way to clearly articulate that.
Yeah.
This is not easy. It is insane how challenging, at least for me, and there's a lot of people who are quite natural at this side of the world, but this is something for me that definitely was not easy. And like the book itself, I mean, I actually honestly wrote the first draft of the book over the course of 3 or 4 days. I've already started on the second book and wrote that over the course of 3 or 4 days. It was the months and months beyond that of actually getting everything else actually working and together that really needed to happen before I felt like we had a good campaign. We had something useful.
Yeah, so the book was really just the tip of the iceberg, if you will.
Yeah, absolutely. Very much the tip of the iceberg, because then you have to think about, okay, writing a script for your video, right? And then and editing and revising, and then getting back to finding a videographer, and then writing the content for the campaign page and figuring out, how are you going to illustrate the various backer levels? And then how do you differentiate the backer levels? And it's a lot of work, but it's also really gratifying when you get on the other side of that and realize, okay, we were at least able to communicate our idea. And in many cases, when you use Kickstarter, funding is validation, right? It's validation that at least enough people believed in your idea and you communicated it well enough that you were able to make it, there's always things you could do differently. I have a laundry list of stuff I will do differently next time. But to feel that sense of like, okay, all right, we got it. We got the point across and enough people think this is a good idea that it's worth doing. And then at that point, the fun part becomes fulfillment.
Pack those bags.
So
you mentioned you've already written the first draft of the second one. Will you go through Kickstarter again to do that? And when do you stop doing Kickstarter?
That's a good question. I will definitely do Kickstarter for the second one because I feel like we're still new enough in terms of this business and this idea that it makes sense to continue to build a base and a community on top of Kickstarter with that platform. Potentially not for the third. We'll kind of see how the second one goes. I do already have the title and the rough outline of the third book. But in terms of the second one, I think there's still plenty for us to do in terms of getting the word out there and maybe iterating on the campaign and some of the ideas or some of the lessons that I learned from last time that we can apply to this campaign.
Sure. When can people expect to see that Kickstarter?
My wife would tell me not to say, but I will. So we're actually going to spend some time this weekend. We're going to pick a date and sort of back it up from there. My hope is to actually launch that next campaign in June. And if we launch it in June based on timelines with our printer and all of those things, we would be able to get the books out before Christmas this time around, which is something that I wanted to do last time because we were launching at a time that there's always that temptation of like, oh, if we say it'll deliver by Christmas, we'll get all kinds of people that sign up. And while that is probably true, it was very important to me to be one of those unfortunately rare Kickstarter campaigns that actually fulfills on time.
Sure.
If not early. Like I really wanted to meet those commitments that we made to our backers. And so we set the fulfillment date out to like mid-March. We ended up being about 6 weeks early, which was great. But I really knew that first time around, I was going to be wrong about some estimates. And so I needed to stay away from Christmas, just not even try.
Yeah.
But this time around, I think it would be really great if we could have. The book makes a great gift. The kits, I think, make a great gift for kids and for other families. And so it would be great if we could actually have that for folks around Christmas this year.
Sure. So you and me, and I think, many of the people who will end up listening to this, all have some device. We've all automated something, whether or not there's buttons or radon controllers or the weather station, the LED lights in our house. We've destroyed stuff. It's led you to a life of also, helping teach kids, and now you're, sleeping with the enemy. I joke, I love Particle, but now you have a job at Particle where, you're entrenched in it from a day-to-day basis. So, I guess, what does the landscape, how do you feel the landscape looks today? Because there's a lot of stuff. IoT is a big, big buzzword. Like where are we in terms of like the reality of, I don't know, is this a commoditized market? Is this something that everybody can get into? Is this?
That's an awesome question.
Are we just reusing old electronic parts that China couldn't stuff into VCRs and refrigerators?
No. I think so. No, I mean, I think it's a great question, because I think the reality of where we're at today is that the hype cycle for the Internet of Things was so steep, and there was a lot of prognostication about trillions and trillions of dollars of opportunity and trillions of devices. That hype created, I think, an inevitable wave of, see, that's dumb. That's not really going to be a big thing. And there's a family-friendly live stream, but the Internet of SHIT podcast is a wonderful, or not podcast, Twitter account is sort of an example of, look at all this garbage and these Internet connected toasters and all of these things. And I mean, I think it's easy to point to IoT and where we are in the hype cycle, in the trough of disillusionment, using Gartner's parlance. It's easy for us to say, this is not a thing. I think in reality, we're still at that point where a lot of the market needs to stabilize. A lot of our expectations around what are real use cases for Internet connected devices. What are some of those things? And within Particle is starting to see that more and more over the course of the last couple of years. And the introduction of Wi-Fi and the Photon was a great example where they were, in the core, and the Photon was a great example of where I think Particle was trying to solve this problem of, why is it that all these devices are Ethernet only? Let's actually create an easy Wi-Fi module. And so they were the first to do that. And then a couple of years later with Electron, and I backed the Electron campaign. I think you did as well, right? Yeah.
Oh, yeah.
Because you and I both back all these Kickstarter campaigns that we probably shouldn't. But that was one I'm really glad I did. And there the problem being solved was, okay, now you've got Wi-Fi, but there are a lot of customers out there with real legitimate use cases that don't have Wi-Fi access. So let's actually make cellular as easy as we have made Wi-Fi. And so I think Particle is a good example of a company that has paid attention to, and full disclosure, I work for Particle. Yeah. It has paid attention to where the market needs to go to solve real use cases, and not just to build hype, but to actually find technologies and find solutions that actually match with what we're actually hearing from customers. And so, the Electron is a great example of where there are customers that were doing things like stormwater management, right? Or creating creating home appliances that have some sort of service portion that needs to be matched to a technician so that you can actually deal with preventive maintenance and understanding how to deal with something before it breaks. Sure. And then with the latest suite of devices, I think we're getting to that point now where, just to answer your question, we're getting to that point where I think we're kind of starting to creep into that place of stability. I can't remember the hype cycle term right now, but getting to that place where, okay, we're legitimately finding use cases. The hype is out there. The hype is dying down. We're actually finding now, I think, some real use cases to solve. And one of the biggest now, I believe, is you've got Internet connected devices. You've got cell connected devices. But what about those scenarios where you don't necessarily want everything connected to the Internet? This has been a bit of a personal passion for me, because I've spent some time over the last couple of years in talks railing against this idea of connecting everything to the open Internet. I've done talks on smart home at that conference around that. I gave a talk last year in Eastern Europe about this idea of everything being cloud connected is not scalable. And little did I know that Particle is actually actively working on something to solve this, which is the mesh technology under their third generation of devices.
So let's come back to that.
Okay.
I feel like we're in this place where, it's easy to come up with an idea. It's easy to go buy a board, or many boards, if you will. It's easy to grab a breadboard, start to get something together. You can get, a half-ass prototype running. You can find out that you can write a bunch of software, and then you can get some cloud stuff involved, be it Google or Azure or one of these, they all have some cloud stack to do machine learning and IoT and send bits all over the place. But the reality of all this is there's still a manufacturing process of kind of taking your idea and then actually making it such that you could sell a product. And I'm sure there's certifications, UL and whatever other home, like don't start my house on fire type stuff. And I mean, it seems like that chasm is quite large to go from ideation to actual, like, on a shelf boxed device. Is it really something that, say, somebody like myself or anybody who's listening who has an idea, are we able to cross that chasm, or is it a place where you need a Kickstarter, and it's big backing, I don't know, big electrical engineers, big presence in China, like?
You mean as an individual, like if you're looking to bootstrap something new? Sure.
I mean, you're not Samsung, right? You're not I don't know, Amazon with their Echo. So I was going to say the other word and then send everybody's off, including mine.
I was just looking to see if mine was muted. Actually,
I mean, it's one thing. It's one thing to build this, right? Take a bunch of stuff, put this together, write some software, make it work. And it's a whole nother thing to, sell an actual Kindle that's a device that, granted the two aren't necessarily equal in this capacity, but.
No, it's not actually. I think that's a great question, because we all get to this point where we want to productize something. Even when we're just sort of messing around. I have a project I've worked on for a couple of years that helps me out with homebrewing stuff that I do at home. And it's a Photon based little thing that I call a brew buddy. It's got a, K-type thermocouple and a little LCD screen on there that actually shows me temperature variations and things like that. And after, milling out or CNC milling a couple of variations of the PCB, or I did the prototype, then I wanted to do the PCB, and then I wanted to do the Osh Park thing and all that, and ordered some custom PCBs from them. That still feels very much prototypey, right? I was iterating on that, but it was really just sort of my own, like, I want to learn to use Eagle, so let me do that. Or, I want to see how cool it is to get a real PCB delivered to my house. Let me do that. But what you're asking is obviously a degree of difficulty beyond that. And I think that's something that we've talked about a lot before. And I know that a lot of developers sort of wonder that themselves. One of the cool things that I came across recently was there was a resource that Particle put out a couple of years ago called From Prototype to Production. I do believe the URL is from prototypetoproduction.com, or if not, it's on our blog.
We'll find it.
Yeah, we'll find it. But what's cool about it is it actually does walk through all of those considerations. When you start thinking about sourcing, it walks through what a BOM or a bill of materials needs to look like in order for you to actually work with your component manufacturer and distributor. It talks about the realities of, do you need to go to China? Do you need to plan to live in China for a little while if you're going to do this? Are there U.S.-based options that you can look at? And there's a swath of resources out there. But what I'm glad to see, and that's only one example, is there are more and more people thinking about this and asking this question. To answer your question, do you need to do Kickstarter in order to manufacture this yourself? I don't think the answer. I don't think so necessarily. I think that component prices are starting to get cheap. You do have your PCB houses like Osh Park and PCBs.io that give you an option to get boards relatively cheaply. There are great services out there in Alibaba and for ordering stuff at scale, DigiKey even as well. I think that it is possible if you're looking at a limited run. I was thinking the other day, there's a developer that does a daily video blog called Daily IoT, Kevin Sidwar. Okay. We'll link to that one as well. But Kevin is actually building this. He's building this device that is this. He's a big NHL fan, and so it's a hockey puck device that gives you updates, sort of daily updates from NHL games and seasons. Okay. And he's doing a lot of testing. And he had a great video the other day about sort of if I want to build a hardware project, do I do venture? Do I do Kickstarter? And I think the conclusion he came to is I don't want to do either. So I'm going to try to explore the third path. And I think I think it is the third path. If you're gainfully employed, if you have the option to spend some nights and weekends doing some of this stuff, I think you can do small scale runs and you can do your MVPs and your beta testing among smaller communities. You don't have to go that path because there definitely are cons to Kickstarter. Kickstarter hardware projects tend to be late, very late. So I think it's created this distaste in many backers to even consider certain projects that seem complex. And then for venture funding, I worry that the VC market treats hardware startups a bit differently than they do software. You're not going to get as big of a return software just because of the fact that you have higher fixed costs. Sure. There are firms that are getting better about this, and it definitely is an option. But it's not as slam dunk as just going and being a VC-backed firm in the software world.
Yeah. You mentioned small runs. Are we talking hundreds, thousands, tens of thousands, tens of millions?
Hundreds, I would say, if you're looking at doing it yourself, because if you're going to do a small run, you're either going to build a reflow oven out of a toaster oven, and you're going to be doing a lot of, you're probably not going to be getting a pick and place machine in your house. Oh, that would be pretty cool. Yeah. So you're, in that sense, not just cost, you're going to need to consider, like, do I want to hand solder 100 different boards? And the answer may be yes, if you feel like that's the best course to get validation. Sure. 30, 40, 50. The cool thing about that is that there are more and more people doing that on sites like Tindy. We should link to Tindy as well. Yeah. Tindy I bought stuff off Tindy. I spend way too much time browsing Tindy because there's an example of where sort of the independent community is saying, I'm not going to do 1,000 unit runs, but I got a cool idea that I'd like to put up here. And if you're doing a hardware, and if you really want to do crowdfunding on the hardware scale, you can look at a site like CrowdSupply, which I've backed a few things from. CrowdSupply tends to be more focused on the hardware community. And I think that audience is more attuned to understanding the inevitable long timelines and delays that come with doing a hardware product.
Sure. You mentioned earlier, let's talk a bit about boards, and let's pick apart some of the particle stuff since it's near and dear to both of us. You mentioned before these are development boards. What's the definition of a development board versus something that goes into our small scale run?
Yeah, so a development board is the board that you'll see today that has sort of the headers soldered in, right? This is a board that's meant to either go inside of a breadboard, right? You pull it into a breadboard, or you put it in your own custom PCB. Don't solder it into the PCB like I did. I still have a core from years ago that I can never use for anything else because I soldered it in to a Adafruit Perma Proto board. But these are your development devices. This is to make sure that your firmware works, to make sure that you get the circuit, the schematic done properly in the reel, and all those things. And then from that point, when you're actually looking at scale and production, there are a couple of different options. In the case of a board like the Photon, you'll see the chip that's on here is referred to as a P0. We have sort of the P1, which is just the chip. And there's a few requirements in terms of what you need to put on your PCB in order to have, the onboard LED and the reset and mode buttons and things like that. But those P1s are your chip that you just drop on a production device. You can buy them at scale. They tend to be a little bit cheaper and things like that. And then with the electron, there are some things that we're working on around, there's an E-series device and some things that we're working on around how you take the cellular devices at scale. But if you're looking at doing cellular at scale, we and others that are in sort of a similar market do also provide the ability to work with our teams to actually to work with you on creating custom PCBs and things like that. One of the things that we have noticed from many of our customers is that they have the same question that you do. Yep. As solos, as indies, we have these questions for our own projects, but even businesses that see an opportunity in the IoT have the same questions. They could be a manufacturer, but not have that expertise. Yep. Maybe they have one hardware engineer on their team that wants to use our stuff, but they don't have manufacturing, they don't have electrical engineers, they don't have your PCB specialists and things like that. And so, we have teams internally that work with those teams to take those ideas to scale in production as well, which is really neat to see. But so that's really the difference is you go from having this sort of header soldered in board into something much smaller that then fits into your PCB design.
More permanent, if you will.
More permanent, yeah, definitely.
Yeah. So, okay, so Photon, electron, you mentioned there's a new one coming this summer. What's the new one and why? Like, did we just not get it right the first time?
No. In fact, honestly, our Photon and electron devices will still be available because there are great use cases where having a device Wi-Fi connected or cellular connected that sort of stands on its own, there are still plenty of use cases like that. But for these new devices, which we're referring to as our sort of third generation of hardware, with the core being the first and the Photon being first, electron the second, this sort of third generation hardware is designed around these use cases where you need to have a number of devices connected to one another or to a network, but you don't necessarily want them connected all to the internet. And so what we're doing is we're creating something called particle mesh. And it's based on the Open Thread specification. That is a open standard specification that's put forward by the Nest folks at Google. There's a big working group working on that. But particle mesh will be Open Thread 1.1 compliant, I believe. And the whole idea is creating a series of devices that now allow you to create mesh networks for your home, for your deployment site, for an office space, for a farm, etc. And the idea behind the mesh network is that you have three different types of devices. You have gateway devices. Gateway devices are those that can help facilitate networking. They sort of serve as your access points, to use a Wi-Fi term. They're your APs for the mesh network. But they also can be connected to the internet. We have routers, which are devices that also can function as gateway, or that may be gateways as well, but they route messages between devices or to gateways, right? So you can think of these devices. These may be the devices that sit halfway between your gateway and a physical device connected with sensors because you're too far away from Wi-Fi or too far away from that device network. So they're bouncing messages between those devices. And then the third type of device is the endpoint. The endpoint is most of the time commonly connected to your sensors and actuators. So if you have a temperature sensor that sits at the edge of your yard for some reason, or a water moisture sensor that sits next to your irrigation control box or something like that, and it needs to make 3 hops back to the gateway that's sitting inside your network closet at your home or your farm, the endpoint will take those readings, send to the nearest to the nearest repeater or router. I used the term router, I meant repeater.
Okay.
So anytime I said router the few minutes, I meant repeater.
Yeah.
Sorry. The repeater will then take the message and bounce it on down the line until they're within range of a gateway, at which point the gateway will then send the message up to the particle cloud or anywhere else that you're actually working with. So that is, from a software standpoint, sort of what happens in creating the mesh network. And we've got 3 devices that are shipping in July, we're taking pre-orders for now, that will provide those capabilities. One is the Argon, which is going to be the Wi-Fi connected gateway /repeater device. The next one is going to be the Boron, which will be our LTE cellular connected device. And then the final is the Xenon. And the Xenon is basically going to be your endpoint, your workhorse. Your endpoint, and actually the Xenon can also function as a repeater. So you can have a fleet full of Xenons, and a couple that are serving as endpoint devices, and others that are bouncing messages between the network out to your gateways.
So I guess I didn't realize this when I originally plunked down hundreds of dollars for the support particle in this adventure. I guess I didn't realize that the endpoints didn't talk to one another. They have to talk through a repeater?
So I will tell you at this point that we are still fleshing out some of the specifics in terms of how the devices talk together. I mean, we're in the midst of building the APIs and things like that. So I can follow up on that one specifically, but I do believe that it's possible if you have an endpoint. So the terms that I use, endpoint router gateway or endpoint repeater gateway, are somewhat separate from those actual physical devices because some of them can serve multiple roles, right?
Sure.
Like the Argon and the Boron are your gateways, but they can also be routers and even repeaters and even potentially endpoints. The Xenon can't be a gateway because it's just going to have Bluetooth and mesh communication in it. It won't have Wi-Fi or cellular. But I do believe that xenons will be able to talk to one another to serve as repeaters.
Okay.
Right. So you don't always have to be, and I think that's absolutely going to be the case, because if you only want to have one central device that speaks to the open internet, everything else is probably going to be a xenon or at least another argon that you're not allowing to make an open connection or something along those lines. So they will be available to sort of bounce those messages.
Outside of like buying the hardware and kind of setting up this like network infrastructure, do I, as the person who's like making the thing to do whatever, I keep coming back to a farm scenario. I don't know why I picture a vineyard in Napa who's like measuring the water content.
That was perfect. Yeah.
I don't know why. I don't know why that's the one that always kind of sticks in my
head. I know
but
that's how you want to retire. I know.
Oh man, there would not be much of the product we'd be selling. I'd be drinking it all. But do I, making the super IoT grape sensor, do I have to care about that stuff other than like I need these? Do I, from like a programmatic standpoint, do I need to care about any of that?
That's a great question. You won't. No. I mean, the beauty of Particle has always sort of been focused on this idea of making it easy for you to do these complex things, right? To get a connected thing online, to have a cellular-based connected thing. And on the mesh products and the mesh APIs are going to be no different. The idea is a lot of what I just described with creating endpoints and repeaters and routers, gateways, you could replicate using a Wi-Fi and local area network infrastructure, but you'd be doing a lot of the network administration yourself. And you'd have to really, really keep it up to date. Our goal and our intention with mesh is to just make it as easy as getting a Photon online, as configuring Wi-Fi, right? We want to make it to where what you're doing is you're setting up that mesh network. We give you all the tools to do it largely automatically. You're defining what talks to what, and then things just work. They just run. And you're not doing a lot of active network administration beyond that point.
That's cool. Query strings and a URL. We use them for everything.
Right. Right. Exactly. So
I mean, if I'm the grape farmer, right, I can, I'm super successful. So I've got, a couple thousand of these things, and, the only thing I really want to plunk down is to where this location is. And quite honestly, I'd rather it just tell me where the location is. And, Absolutely. Messages start to flow and my grapes get big and plump and juicy and whatever.
Yeah. And then there's wine for you.
That's right.
And a few bottles for the customers.
Somehow I'm a super like tech nerdy grape farmer, but
Yeah. Now I can tell you the particle mesh stuff is going to be awesome, but it's not going to be able to speed up the aging process or the fermenting process of your wine.
Then
I don't work on that yet, so you're still going to have to wait.
Okay. I didn't plan for that.
I know you're disappointed.
I'm just going to inject these things with little photons of resistance that would make them awesome.
Maybe when we get smart dust, that's that. Maybe when we get smart dust, that's the thing. That's one part of the IoT buzzword problem, right?
There you go.
Sensors that are so small that you can just blow them in another person's face. That'll be wonderful.
Living in one's soul.
Okay, exactly.
So a lot got said. There was a lot of places, and we'll certainly link up those below, all the different sites you referenced, whatnot. So you'll have to help me do that.
Sure.
Where do we get started? Like, what's the place to, I don't know, become more competent with this stuff?
Just making in general?
Sure.
I think it depends a bit on where you have come from. If you're coming from the software world, which I know, most folks that will be watching and we're talking to are going to be in that space. You've got a lot of options. I mean, I definitely want to respect the fact that you could definitely get a SparkFun Inventors Kit. You can get an Arduino. You can get, Adafruit Circuit Classics and start using Circuit Python. You can grab a Photon and, start. One of the things I love about the Photon experience is you can grab a Photon and you can actually start coding inside of the browser. So you can you don't have to even get it connected up to USB. As long as you can get that thing on Wi-Fi, you can actually do something really quick, which is kind of a neat experience. Sure. Adafruit has some of that as well inside of the Circuit Python. There's Microsoft Make Code, which actually gives block-based programming on their Circuit Classics board, which is really cool. I've done that with my kids as well. And if you're looking for something to do along with your kids, I mean, I would definitely look for something that's kid-friendly that they'll get excited about, but don't steer them away from code. I think it's okay for kids to learn to actually write code. The block-based stuff, I think, is great for teaching programming concepts and for kids to start to understand variables and flow control and some of those types of things. But, as soon as a kid can get behind a keyboard and feel confident, I think they can start thinking about writing code.
Fortunately, the only thing I can get my kids interested in is a Nintendo Switch. So
I have that, I have that same problem right now. They haven't quite yet beat Mario Odyssey, so that's all they want to do. Yep. I got a thing with the Switch because there's the Nintendo Labo thing that's coming out next month, right? Where you can do like the cardboard-based devices that use the IR ports and the Joy-Cons and whatnot. You haven't seen this thing yet?
No, I haven't.
Okay, I'll just send it. Okay, so it's basically, you're creating the first example I've seen of a maker kit, like with a console. You're building this like cardboard automata kind of stuff and firing guns at the screen and building a robot and things. I gotta feel like eventually it would really be cool if the Switch of Nintendo started getting into some of like this Scratch stuff and, more of the electronics education side of the world. Programming would be really, really neat. But frankly, I think what it comes down to is I'm biased. The Core was one of the first boards that I bought. Yeah. I think the same for you. I would go with a Photon. I would grab one of those devices, use the web IDE, start going through the tutorials. But you can't go wrong with Circuit Classics, especially if you're a Python programmer, because Circuit Python is really, really neat and becoming more powerful by the day. So there's great opportunities around that as well.
What about the electronic side of things? The learning the resistors and the capacitors.
So this has become one of the things that's been neat about going through writing this book and creating the company around this is that after I went through all the Arduino stuff and I actually a year or two later went back to like, okay, well now I think I want to teach myself sort of basic electronics theory apart from the microcontroller. Like it's one thing to write code to blink an LED, but could I actually do it with nothing but just components, just passive components? And so that, I've obviously continued that journey as a part of writing the book and now writing the second book. So for those that are listening, this is actually a representation of the circuit from the second book.
Oh, look at there.
So folks that see this will be among the few to know. It's blinking. Basically, this book the exercise will be blinking 2 LEDs with a 555 timer chip. So there will be new characters, which is exciting as well. But that exercise, that journey is one that I can't say that there are a ton of great resources yet around. I mean, I will say again, bias, if you go to carrotpantsstudios.com and if you haven't bought the book yet, in the store, we actually have a version of the book with a component kit for assembling that circuit. It also includes a digital download to a 50-page PDF that I put together that has not only step-by-step instructions for building 4 or 5 different circuits, but also includes detailed descriptions of the components and how they work together, and just some of that basic electronics education. Because I think that's what a lot of people are sort of hungry for now as well, especially kids, is, okay, this is a complex world, but what are some of the simple things that you can do? And I've gotten books before that are meant to, like one of these books that I really, really like, Practical Electronics for Inventors, is a great book, but it's barely targeted at me, much less a kid. Like I feel like I can hardly understand it. So there's an opportunity for a lot more stuff, which is why we're trying to sort of take that approach of the story to drive kids' engagement and interest, and then hands-on activities that deepen that knowledge and understanding beyond that.
Sure. All right, well, we've been rambling for a while, so with that, before we end, at the end of every one of these, I extend a bit of gratitude to the person who's come on, and to that spirit, I want to thank you for the work that you've done, putting, kind of chasing your I'll say your itch to write and bring the maker stuff together and create a company that's got a book that has given a number of kids an opportunity to explore a thing that they certainly couldn't have done 20 years ago, let alone 10 years ago. And, you know, blow up a bunch of LEDs because you bought a bunch of parts from China. But, you know, I'm not going to, it wasn't me. It was not me.
Hey, I'll send you more. I have extras if you want some. I'll send you more. Yeah.
But with, you know, in all honesty, you know, thank you for spending the time to do that. It's a labor of love. And I can tell you're driving around a Ferrari because of it. So, you know, sweetness. But no, thank you. I'm looking forward to seeing what we get to do at that conference this year. Which brings me to my last question. Given this world of devices and making and software and the convergence of everything and all the noise that's out there, what would be your tip, your advice for anybody who's either looking to start or has an idea that wants to take it beyond just ideation? What's your carrot pants particle advice to anybody out there?
My advice is there have never been more resources online. So jump on Google, find some, you know, look for things, go to particle.io, go to adafruit.com, check out some of the stuff that's out there, read tutorials, and hit me up. Send me an email at brandon@particle.io. Hit me up on Twitter at Brandon Satrom. Let me know what you're building. I am happy to help steer you in the right direction if you got questions. If you're doing stuff with just bare electronics and you need some help, there's some great resources out there that I'm happy to share. But if you're looking to build something with a board, there's a lot of great stuff out there as well. And really the sky's the limit. I have to say probably the toughest choice today is making a choice among the bevy of options out there. But there's nothing wrong with just picking something that looks good to you, that fits your price point, and just starting to build.
And we didn't really talk about price, but these things are pretty cheap. I mean, the Photons.
They're so cheap.
$9, $19, something like that.
$19, yeah. And then the new mesh stuff is relatively cheap. If you get in the pre-order, the mesh stuff is super cheap right now. So yeah. And then beyond that, I mean, the Raspberry Pis has stayed cheap and just gotten more powerful. Yeah. Adafruit Circuit Classic stuff is relatively cheap. I mean, there's some awesome stuff out there.
Yeah. And it's Pi Day, and the new Pi just shipped, and it's more powerful than, 14 space shuttles.
It's awesome. The thing that stinks about it is it didn't ship yet. It's like they announced it today. No, and then I went on Adafruit and it said, "Oh, it's not out here. Sign up for like back in stock notifications." And I was like, "Ah."
"Oh, that's."
But I will have one.
Yeah. I have a stack of them that I've yet to really do anything with. I got the one on Kickstarter from the guys out of Dallas who had the great video, and they had I don't know if it's called the Bolt or something. I don't know. But he had a really good video, and I was like, "Here's my $15. Like, I'm not going to do anything with this." But he did a really nice job.
Another topic for another time, but a good Kickstarter video is like worth its weight in gold. It's kind of nuts. So
it's worth $15.
You got a stack of pies. I'm thinking you probably should just set up a Bitcoin mining rig, right?
Yeah.
We get to go.
It was a great last week tonight on the whole cryptocurrencies that had me just.
I haven't watched that yet. I need to catch up.
All right. Well, before we start rambling, let's end it there. Thank you for joining us today. For anybody who's out there, we'd love to hear what you're making, how you're making it, your tips, tricks. Leave them down in the comments, and we'll riff back and forth. Give us a thumbs up, share it. Our marketing budget is 0, so. Anything you can do to help that. If you want to be on, you know where to find me. Brandon, thanks again for being here. I enjoyed the conversation, and it's time to go make some blue smoke.
Do it. Me too, Clark.
All right.
Have a good one, man.
You too.